Hey, Numberphile. This is Serpinski's Triangle. So I was just watching, watching the latest Numberphile video, Chaos Game, 15 hours ago as of right now, and I watched it about 9 hours ago, maybe 10 by now. And I was very quickly inspired to implement what I learned in that video into a Python script. So this script is publicly available in my GitHub repo here. The triangle. I'll put the link to this in the description and grab a fork of it if you like and do with it whatever you choose. Really, if you want to contribute, feel free to make a pull request and I will see about implementing that. So, uh, just a quick look at the code here. There's quite a number of lines here, 288, 142 of those are code. Some of this is not my code. I used graphics for a lot of it, and pill for creating a picture. So what this does is it generates a Serpinski triangle using what you would learn in Numberphile's Chaos Game video, which basically says that if you pick a random point inside of a triangle and then randomly select a vertex and move halfway towards that vertex, then pick another random vertex and move half the distance to that vertex, and repeat, um, you'll get this pattern called Serpinski's Triangle. So check that video out if you haven't seen it. Um, so just a quick look at where the meat of this is in this function right here. So what it basically does is it figures out where it is, or what the last point that was written is, um, and then decides based on random numbers which vertex it's going to move towards, and then moves half of the distance towards that vertex. Now, one limitation in this right now is that it isn't actually using a random point to start. The maths to try and generate a random point inside of a triangle are a little bit above my pay grade, so I'm just using a preset point, which is directly in the middle of the triangle. Generally, if you mess around with these settings a bit, it can kind of change that, but eventually this will get ironed out to work more fluidly. I just need more maths. So right now I have it set to create 15,000 dots, so let's just give it a run and see what it creates, shall we? So we're going to get this black at first, and in that time it was just creating all of the points. Oh, I think I actually removed I removed the print. But anyways, now once it's created all the points, it draws them to the screen, and then it converts all of the points into something that can actually be turned into a picture, and then it turns it into a picture. So unfortunately, I can't really show you this whole image in this because my monitor isn't big enough. Well, this is a virtual machine, and the virtual machine display isn't large enough. So we're just going to close out of that. We'll take a look at the picture. So yeah, this is the Serpinski triangle that came out of it. And I can kind of modify that a little bit. So the bottom middle, we're going to move it over to the left a little bit. And then run it again and see what comes out instead. So you'll quickly see that there's a little difference in how these dots are forming on the screen. So this should take about 15 seconds. And once that is done, we should have a new image, which I should have closed this one first. Hopefully I did that in time. Now look at this. Yep, now we have a new Serpinski triangle. And this coloring is all done with RGB values based on the location of the dot. So you can come up with some pretty cool coloring methods. Right now I'm using this function here, which uses RGB map, which is a function I made that pinches a value to between 0 and 255, which is an RGB value, and then it uses the location, the actual dot, to determine those red, green, and blue values, but the blue value is just set to 200 because I like blue. And then there's the RGB map function there, and DFC is used in another method somewhere. But anyways, that's just this little thing I threw together that was inspired by Numberphile. So thank you, Numberphile. Wanted to put this out there. So if you are interested in taking a stab at messing with this code, the Git will be in the description, and you can just fork it or clone it and do with it what you like. So yeah, have a good one.